one your R value is, the stronger the relationship is. The closer the plotted points are to the line of best fit, the more accurate and reliable your conclusions. So we've been talking about this. I've been touching on it, saying we're going to get to it, and lesson 10 is when it describes and lays it out for us that this is the strength of a correlation, that R value really pinpoints this strength. The closer to 1 or -1, the stronger the relationship. Here on the board in front of me, I have a graphic that has an R value descriptor line. It's kind of like a number line, and it tells us right in the middle there is 0. Now, if you have an R value close to 0, your correlation is going to be very weak. And if it's close to negative, if it's close to 0 in the negatives, it's a very weak negative correlation. If your R value is in the positives, close to 0, it'll be a very weak positive correlation. And then you can see as we move from the middle out towards our sides, we have +1 on the right of the number line and -1 on the left of the number line. And you can see that the closer you are to that +1 or that -1, we have very strong correlation. Whether it's positive or negative is how close it is to that +1 or that -1. If you're just driving around and you're listening to this class over the radio and you can't follow along with the slides, I do encourage you to go back and watch our recording. They are posted to YouTube, and it gives you a chance to see these visual aids to help you remember what it is that we're looking for. And it's especially wonderful for visual learners who can see what it is that I'm describing and talking about. For the auditory learners, hopefully my description is enough that you can create your own mental picture. I have another practice question on the board that says, decide whether or not the following scatter plots have enough data to present a valid conclusion. So here in our first example, we have very dispersed data points. You can't really form a shape, a line that goes through. It's hard to see, is it positive, is it negative? There's no correlation. It doesn't appear that there's a correlation, and that's because you couldn't put a line through all of the scattered plots. To affirm our thinking, we can look at the R value that's present. So in our first graph, we have these 10 data points. They're very sporadic. They're not a great line of best fit, but then we see our R value is 0.21, and that confirms that it is a weak correlation that we would not consider valid. Because 0.21, if we think of that number line, we have our 0, +1 on the far right, -1 on the far left. Remember, the closer you are to 0, the less strong your correlation is. So it's not valid because 0.21 is really close to 0. Now the next graph that I have on the board also has these 10 points that are a little bit more tightly clustered together. We could say that there's probably a positive correlation. We can see there's a little bit more of a shape going towards up to the right. We could say that there might be something behind this study. However, when we look at our R value, and if we really had to put our, if we were going to put money on this and back it up and, put our job on the line, we wouldn't feel that confident because it's not a strong enough correlation. The points aren't closer to our line of best fit, and we look at that R value that says 0.45. So again, On our number line, where we have 0 being very weak and +1 being very strong, we're not even halfway. We're at the 0.45. So I wouldn't consider this a very strong correlation. The next point that I want to bring up, and if you turn the page to 34 of Unit 2, you'll see we come back to outliers. We're talking again about that point that lies far away from the main cluster of points. It needs to be included because it's part of the research, but it's not really with the rest of the data. That's an outlier. And we know now that an outlier may be caused by either inaccurate measurements or it could just be an unusual fluke. But regardless, it's still a valid result and it has to be included. The line of best fit should reflect all valid points from a data set. So this includes the outliers. Just because we don't like it, it skews the strength of our research. We can't ignore it. If most of the plotted points are clustered along a linear path, even a single outlier can affect the path of the line of best fit. And we saw this with previous examples in the past, and we're going to try it again here with another practice question. So here we have to decide whether or not the following scatter plots have enough data to present a valid conclusion. We see a really strong line of best fit, and then we have 2 outliers. But if we really look at our data, we can see that the outliers actually balance each other out. We have in graph A, we have a really strong line of best fit that passes through most of our data points, and they're really close to our line of best fit. Then we have an outlier on top and an outlier on the bottom, but because of where they're seated, they actually balance out our data points and make it so that we still have a strong correlation. This line of best fit does divide our data points in half. If we move over to our second graph, we see we have a lot of data points. Remember, the more you have, the better, so this is a really good one. And if we draw our line of best fit, we can see that it passes through many of the data points and the others are really close to that line. However, we have this outlier that's sort of top and left, and that one outlier is going to skew our line and pull it, which then makes it a little bit of a weaker correlation. So we've got a tight cluster close to the line, but that one outlier has to be included, and because of that, it is going to skew our line of best fit. And that was really all that lesson 10 talked about. So it was a short lesson, gave a lot of background into it. Hopefully that background helped and made you confident for the groundwork that we needed to lay in order to move on to lesson 11, where we are going to talk about survey design. So going back to lesson 11, looking at our lesson 10 recap, we know that reliability refers to the consistency of a measure. We know validity refers to the accuracy of a measure. Valid conclusions are unbiased, they are accurately measured, and have graphs that accurately depict the data. So the beginning of lesson 10 was me talking about how you can readjust a graph to work in your favor so that visually it's kind of playing on your mind and making results seem more than they are or less than they are, depending on what you're trying to push. The lack of data can result in weak correlations between variables. We know that a low correlation or low reliability can also lead to weak relationships between variables. And outliers can significantly affect and distort data, but they must be included. So today we're going to move on and explore surveys and questionnaires in Lesson 11. We will better understand the components of and how to design a survey. Our learning goals for Lesson 11 are that we will be able to explain what a survey is and how to conduct one. We will understand the role of data management as used in the media, advertising industry, and various occupations. When thinking of surveys, the data collected from surveys can either be factual or subjective. So factual is based on facts, subjective is based on opinions. Keywords that we're going to get into today are again statistic. It's a piece of data from a study that is part of a large quantity of numerical data. A sample is a representative number of participants in a study. Not every single person, but a representation of the people that we're looking at. So that's a sample. Sampling technique, again, is the process used to select the individuals from a population who will be studied. That's how we're going to decide who our sample will be. Bias is an emphasis on characteristics that are not typical of the entire population. We're really trying to pump one thing. That's a bias. Validity refers to the accuracy of a measure. Remember how well true findings are represented. And reliability refers to whether or not a measure is consistent. Can it be replicated? Can it be reproduced under the same conditions? When we talk about population, we're saying the set of all things or all people being considered. That's the population. Now, a target population is a population or group that researchers are interested in researching or analyzing. We're honing in on one group, on our target population. Surveys are used for multiple things. They can help businesses. Knowing what customers want can ensure success. They can help or be used in news media, government agencies, political candidates. They need to know what the public thinks. By polling or surveying constituents, they can have an idea of where the mentality thought is. Associations want to know what their members want. Large companies want to measure the attitude of their employees. To find this information, one would conduct a survey. In the media, you might come across statistical terms or expressions such as percentile, quartile, poll, survey, margin of error, mean, median, mode, range, ratios, percent increase or decrease. All of these are common words that you might come across when dealing with statistics in the media. It's important to recognize and understand common statistical words that the media uses, that's used in the media, so that we can make decisions based on data, so that we're not cheated or taken advantage of due to lack of knowledge, so that we can be informed citizens who are able to understand issues in the world around us that involve data. And the first step is to recognize what we're being presented with and to think critically. So we practiced that at the beginning of Lesson 10, looking at all the different misuses of data, how we can be led astray by being thrown visual graphics, numbers, percentages. When we have a lot of statistical data coming at us, it can be hard to decipher, and you say, oh, well, yeah, that looks good, sure, it must be true. But that's why we want to really look at, what is the y-axis? Is the scale appropriate? Are we being misled with 3D images of bar graphs? We want to be able to understand information that involves data. When we are looking at sampling a population for information, it's important to note that the sample size can affect survey results. If the sample is too small, the results may not be reliable. And that's just like all the scatter plots that we've been looking at. If we sample a small size, we're only going to get a small amount of information. That's not enough data points to plot and have a strong correlation. But the opposite is also true. If the sample size is too great, the survey might not be accurate because it can be difficult to administer, difficult to track. It will definitely be costly for the person trying to find the information. So you really need to think about your sample size when you design a survey. When we talk representative sample, we're saying that a sample needs to be typical of the entire population. This is a representative sample. It is representing the population as a whole. If the sample is not representative, then it is biased. And once it's biased, the survey results become invalid. We talked about sampling technique, that there are many different ways to find a sample, to find a group, to target a certain population. Some sampling techniques are random, where each member of the population has the same chance of being selected. A non-random technique may not yield a representative sample. If it's not random, you're risking running into bias and not having a representative sample. So when we break it down, we know that sampling techniques can be random or non-random. Random sampling techniques, there's simple random sampling, there's stratified sampling, there's cluster sampling, systematic sampling, and then non-random can be convenience sampling, judgment sampling, voluntary sampling. Let's practice a question together where we want to see if it's a strong design or not. The question I have on the board says a town has a population of 20,000 people. The town council conducts a vote at a public meeting about constructing a new ice hockey rink. The question says, what % of the people at the meeting voted for the rink? So here's how we start to look at the math, the numbers, the percentages of the information given to us. So what we know is that 50 people attended the meeting. 40 of the people at the meeting vote in favor of the hockey rink. Therefore, the council decides to build the hockey rink since 80% of the people support the idea. That's pretty strong. 80% say yes. So let's see if A, the math is right. We want to find out how many people are voting for it. So if it's 40 out of 50 people, out of can be division. So 40 divided by 50. We can look at what is 40 divided by 50 to see that that equals 0.8. Now, remember when we have a percentage, if we have 16%, we'll say, and we want to find it as a decimal, when in lesson 1 we were trying to put interest rates into our formula, we had to express it as a decimal. We divided by 100. There are 2 zeros in 100, so we knew we had to move the decimal place 1, 2 to the left to give us 0.16. Now we have a decimal. We have 0.8. So instead what we're going to do is we want to put it into a percentage. So we're going to go the opposite way. We're going to multiply by 100, which means because there are 2 zeros in 100, we're going to move our decimal place 1, 2 to the right. And now when you move your decimal place, we need to put in that placeholder a 0. So when we move our decimal place, we have 80.0. So that means we are looking at 80%. All right, so the numbers are right there. What percent of the people at the meeting voted for the rink? 80% supported the idea. The next part of the question says, what percent of the people in the town attended the meeting? So 80% who attended voted for it. But what percent of the people in town attended the meeting? Well, it says at the beginning of our question that there are 20,000 people in this town. So there are 20,000 people in the town. That means that we want to find 50 people attended. 50 people attended. But there are 20,000 people in the town. That's the population. So what we want to do is we want to find 50 divided by 20,000. When we do 50 divided by 20,000, we get 0.0025. Now remember, we want to make it into a percentage, reading the question carefully, what percent of the people. So we need to change 0.0025 into a percentage. When we're going from a decimal to a percentage, we're multiplying by 100. So we're moving that decimal place 2 to the right. Then we get 0.25%. That means that only 0.25% of the population of the town's residents attended. We're not talking 25%, we're talking less than 1%. So when you think of it that way, let's go to our next question here, which asks, is the sample representative? Justify your answer. When you're going through your key questions, if it says justify your answer, that means you're going to have to give a word answer. You need to explain. You can't just say yes or no. You have to expand. So is the sample representative? If less than 1% came out to attend this meeting, then is the sample representative? Not even close. So the sample size is too small. Therefore, and you can use those 3 little dots in a triangle to represent therefore, results may not be reliable. Now, why might this be? I mean, they held this meeting, they asked people who came to vote, so is it their fault that the results may not be reliable? Not necessarily, but it could be because of how they designed their survey, of how they designed this vote. It could be because you asked a voluntary sample. Only people who could attend this meeting. Maybe this meeting was at 10 a.m. on a Tuesday morning, and a lot of people are working then. So only people who could attend could vote, and that's not really fair of the population as a whole. The people who attended have an opinion about the arena. If I don't care about a new arena coming, I'm not going to take the time off work to go. So you're already asking a very specific group what they want. So the people who are coming are the people who want it, they're pushing for it, so they're going to take the time, so then it will get pushed through and it can happen. Now, as we get through lesson 11 and we're talking about survey design, you will see that a lot of times those are the people that you want to ask. We don't necessarily need to know from the people who don't ever use the arena if it needs to be rebuilt. They wouldn't have a complete understanding of what an arena needs, what it looks like, what is falling apart or breaking down or outdated. So we are going to go through the different survey design elements to look at how do we conduct an appropriate, unbiased design that will get us the information that we need. We need to start by looking at biased questions. Biased questions restrict people's choices unnecessarily, or they use words that could influence people to answer in a certain way. For the results to be valid, survey questions must be unbiased. Then we need to look at survey technique. Another factor to consider is how the survey is conducted. This is especially important if any of the questions are about sensitive subjects. People are more likely to answer honestly if they can reply anonymously in writing. If you ask somebody face to face a super sensitive question, they are going to be guarded. They're probably not going to give you a truthful answer. They're going to give you an answer that they think is right or that they think you want to hear. So looking at our next example, where people were asked this survey question in phone interviews. The question is, we harm the planet when we use pesticides on our lawns. Should the government ban all residential pesticide use? The first part of the question says, will the survey results be valid? Well, let's look at the wording that's used here. We have very strong words like harm. We harm the planet when we use pesticides on our lawns. So already you're giving this negative connotation that is leading. So it's setting you up for how you should answer. We harm the planet when we use pesticides on our lawn. Now I'm going to ask, should the government ban all residential pesticide use? Well, obviously, because you don't want to look like somebody who's a planet killer. So you have to be careful when wording, because this wording is very leading. It's leading, it's biased. Therefore, the results are not valid. So then the second part of the question is, if you feel the survey is not valid, how could it be improved? Well, for starters, you can conduct this anonymously. This could be a written survey, not over the phone where they're going to hear my voice, but if you do it as a written survey, then I don't have to feel the heat of the person on the other end. I can give honest feedback. If it's anonymous and written, you don't know that it's me saying it, then I can give honest feedback. Here's another example. About 4,000 people visited a large sports equipment store during its annual sale. The store surveyed 100 customers after they paid for their purchases. An employee is standing then at the checkout line at the end and records the answers. So the first part of their survey says, good sports equipment can greatly improve performance. How much do you spend on equipment each year? And it's kind of a scale. There's $200 or less, $200 to $400, $400 to $600, the $600 to $800 range, the $800 to $1,000, or more than $1,000. Once you check one of those, the second part of the question says, how much do you earn per year? Do you earn less than $10,000, between $10,000 and $20,000, between $20,000 and $40,000, $40,000 and $60,000, $60,000 and $80,000, or more than $80,000? We are recognizing right off the bat that these survey results are invalid. Why? Why would we say that these results are invalid? What could be wrong about conducting a survey this way? And the answer is there are quite a few. For starters, we are only asking the people who actually paid for the purchases. We're only asking the people that came in and spent money. We're then asking them in person. we are putting them on the spot. How much did you spend today? And is that indicative of what you spend in a year? And then we're kind of leading. We're leading them by saying the more you spend, the better you are. Good sports equipment can greatly improve performance. So if you are spending more than $1,000 on sporting equipment, you must be a fantastic athlete. And most of us like to puff up our chest and say, we are good at something. And so this can get us to give false information. I'm not going to tell somebody that I just spend $200 or less a year. They'll think I'm not athletic. They'll think I don't take it seriously. They'll think that I'm not good at sports. So I might overinflate my answers. But then to follow that up, they want to know how much I earn per year. So if I'm standing there next to a very good looking athletic gentleman who says, Kobe, how much do you earn per year? I might inflate my salary as well to make myself look more important or better and then hopefully gain favor in their eyes. This survey could be improved by just having it in writing, giving it to everybody at the beginning when they first walk into the store, and letting it be anonymous, letting them drop it off in a box as they leave, whether they've bought something or not. We can change the wording. We don't need to preface it with good sports equipment can greatly improve performance. We can get rid of that. And we can just say, how much do you spend on equipment each year? On average, how much do you spend? Maybe some years you spend more than others. And when you ask sensitive information, like how much do you earn per year, you want to be able to give them the chance to have it written and anonymous. Don't ask for their name or address. Let them just check off a box, fold it up, put it into a lockbox, and then you will get a more honest answer. Let's look at the second part of this. There are 4,000 people that visit a large sports equipment store during its annual sale. The store surveyed 100 customers after they paid for their purchase. What do you think of the sample size? There are 4,000 people visiting, and they're asking 100 of them. Well, let's find out what the sample size is. There is 100 people of 4,000. So what is 100 divided by 4,000? Again, we get a decimal and we want to put it into a percentage. So that means we're going to multiply by 100. We're going to move 2 decimal places to get 2.5%. 2.5% of the population is not large enough. Therefore, not an accurate or large enough sample size. We want to be getting the majority of people coming through, and 2.5% is really low. The second part of that question, now that we know the sample size isn't enough, is the sample representative? Are we asking enough people? Is it fair and typical of the entire population? Well, we've already established that all we're doing is asking those who paid. So if we're only asking people who paid, are they representative? Definitely not. They're not representative because you only surveyed people who bought or made a purchase. It doesn't represent people who visited but left without buying. In order to make this better, we could do random sampling. You could ask every 10th person who comes into the store. You can do systematic sampling. You can vary it so that you don't have to hand out 4,000 of them. You can have a better sample size, but making it random, making it anonymous, making it written will all help the validity of the survey. And the last part of this question we've already answered. Are the survey questions unbiased? They are not. Because we are leading with 4,000 people, with good sports equipment can greatly improve performance, we're leading. We're wanting them to say that they spend more. Was the collection method appropriate? No, we've already talked about how we want honest answers. You need to consider asking questions that match your goals. If you really want to know how much people are spending and why, then you want those honest answers, and you're going to want to consider the written and anonymous. Looking closely at Lesson 11 on page 2 of Unit 3, we're getting into survey design. Knowing what the client wants is the key factor to success in any type of business. News media, government agencies, political candidates, they need to know what the public thinks. Associations need to know what their members want. Large companies need to measure the attitudes of their employees. The best way to find this information is to conduct a survey. There are various steps involved in a survey project. The first is to establish the goals of the project. Second is to determine your sample. Third is to choose your interviewing methodology. And then fourth, you can create your questionnaire. So the first is establishing goals. This is, what do you want to learn? What are you trying to get out of this? What's the information you're trying to gather? The goals of the project determined whom you will survey and what you will ask them. If your goals are unclear, then your results will probably be unclear. You can't have it too broad, too sporadic. It needs to be focused, and then you'll get focused results. When selecting a sample, you're asking, who is it that you're going to interview? Decide what kind of people you're going to interview. This is your target population. Correctly determining the target population is critical. As we found out with the ARENA survey, when you're only asking certain people, of course you're going to get a certain answer. But then sometimes if you're asking the wrong people, you're not going to get a clear answer at all because they don't know anything about the topic or the situation. So correctly determining the target population is critical. Next, when we talk about determining sample size, it's how many people are you going to interview. Decide how many people you will interview, knowing that a small representative sample will reflect the group. Remember, too many, it can skew your results, it can be super costly, and not enough, you won't have a strong correlation. So when you are considering sample size, you can determine your sample size based on factors such as time available, your budget, and your degree of precision. Oops. When you want to avoid bias samples, it's almost impossible to avoid all bias. Let's just be honest, be upfront, call it what it is. However, being aware of bias helps to discount some of the answers. You'll know then where it's coming from and why. We have 5 minutes left, so let's go on to interview methods. How will you interview your target population? There are numerous interviewing methods. You can conduct personal interviews, telephone surveys, mail or email surveys, internet or intranet web page surveys. There are advantages and disadvantages to the different types of interviewing methods. If you look at the bottom of page 3, we're jumping into the personal interviews. The advantages of personal interviews are that the interviewee, the person who's being asked the question, can experience the product. They can test it out, they can look at it, they can hold it. The Other advantages to personal interviews are the ability to find the target population, and longer interviews are sometimes tolerated. If somebody stops me in a mall, sits me down, asks me questions, it's a lot harder for me to get away. I feel more guilty when I'm face to face, whereas if somebody's droning on and on and on over the phone, I can just hang up and not feel super guilty. So there are those advantages to having that personal touch, that face to face, that ability to experience the product. Now, on the other hand, a disadvantage of holding personal interviews is that it's more costly. You've got to pay somebody to be standing around for a day, to be interviewing, to ask the right questions, to ask them neutrally. There's that biased wording, the leading questions, but there's also how somebody asks it, their tone. So you have to be careful that you have a good interviewer who is knowledgeable about the product, who is invested in your survey, and isn't going to skew results. Now, the other problem with personal interviews is you can get a skewed target population. If you're just standing around the mall, you might not be targeting the people that you are hoping to get. Another option is telephone surveys. Telephone surveys are great for reaching wide populations and fast. You get quick results. You ask a question, they answer. You get it right away. You can have randomized population if you get a list of random phone numbers. You can have skilled interviewers who can draw out more of a response. They can say, okay, and what about this? Or tell me more about that. They can get more out of an answer, as opposed to written, where somebody just, oh, I think this is what they mean, and they're going to write that. Having somebody both in a personal interview and a telephone survey, you can have a skilled interviewer who can help explain and draw responses without leading bias, ideally. Now, the disadvantage to a telephone survey, there's that telemarketer stereotype. You're just a telemarketer, I can hang up on you. People can screen your calls. Sometimes they often will call at inconvenient hours during supper time when they know that you're done work, and it's not ideal. It can be costly to pay for that random list of phone numbers, and you can't show or sample products over the phone. I can't test it out. I can't see what it is you're talking about. It's over the phone. There are other surveys that we will we'll pick up tomorrow and continue talking about, but it's all the time that we have for today. So I hope you have a great rest of your afternoon. We'll